In this lesson, we'll look at the difference in compounding something continuously versus compounding it daily. Let's start with a quick overview. Both scenarios are modeled using exponents. Except for continuous growth or decay, we use the base e. And when it's not continuous, for example, daily, monthly, or annually compounded, the base used depends on the number of compound periods. Let's read the question. How much money would be in an account after 5 years if an original investment of $6,000 was compounded continuously at 4.5%? Compare this amount to the same investment that was compounded daily, round to the nearest cent. To find out exponential growth using the base e, we use the following formula. And the variables for this formula are explained underneath. Let's write down what we know. We are told that the original investment, which we call our principal, is 6,000, and p is found in both formulas. We are told that it is continuous for 5 years, and we will represent t as the number of years, 5. That's found in both formulas again. And 4.5% will be our value for r. R represents the interest per year. And we need to convert that into a decimal. So I have r is equal to 4.5%. We divide it by 100%, and we end up with 0.045. Let me substitute these values into this formula. I have A is equal to 6,000 times E, that's approximately 2.71, raised to the power of R, 0.045, times T, which is 5. Okay, using our calculator, 6,000 times E, that's accessed by clicking Shift and this button right here, ln, 0.045 times 5. Now, it's recommended that you don't use 2.71, the approximate value for E. It's best that you actually use the function that's found in your calculator or more digits after 7.1. And I end up with 7,513.93. They want us to round to the nearest cent, which means 2 decimal places. So 7,513.94 cents. Okay, that's the cost if it was compounded continuously. What if we want to do it compounding it daily? For that, we will use the compound interest formula. And the compound interest formula is right here. It has one other variable that's not found in the other formula, which is n, and represents the number of compounding periods. Obviously, we're talking about days here, daily, so n would be 365. I have A is equal to my principal of 6,000, bracket 1 plus R, 0.045 per n, which is 365 days per year. And that will be raised to the power of n, 365 times t, which was 5. Okay. Let's use our calculator, see how this differs. 6,000 bracket 1 plus 0.045 divided by 365, close, raise 365 times 5. And it's recommended that you do this all in one step on your calculator so that you don't run into any rounding errors. We end up with 7,513 decimal 83. Look at the difference. When something is done continuously, you get more money out of it. As opposed to 83, we have 94. And you would expect that because if something is done continuously, that means it is broken down to a point where n is going to infinity. And when that's the case, you end up with Euler's number and you get more money out of it. Now, you don't see things compounded continuously very often in banking, for example. Most of it is done by compounding it daily or something within that parameter. Anyway, now you see the difference between compounding something continuously versus daily.